Our theorem is if D is GCD of A and B for all A and B are not equal to 0, then D can be written as linear combination of x and y. In other words, we have to prove that D can be written as in this form. Okay. So first of all, if we understand this theorem with the help of example, that's very easy to understand. I am taking an example 243 and 120. I am going to find out the GCD of 129 and 243. Okay, it goes on 1 times 1 to 9, and I have here 4 1 1. Okay, what is it here? This is, as you know, that A dividend, this is divisor B, and this is remainder. I give it name R1, and this is Q1. As you know that I can write this expression as 129 multiply 129 multiply 1 plus this remainder 114, this is equal to 243. If I multiply 129 with 1 and add 114, then its answer is 243. You see here, if I multiply this, okay, to this and add remainder by Euclid theorem, and you see that here R1 is greater than 0. Okay, as you see that 114 is greater than 0 and 129 is greater than 114. So what we have given the names to them, yes, this is A, this is A, this is B, and R1 plus, no, this is Q1, this is Q1, this one is Q1, and this is R1. What is here? This is R1, this is R1, and this is B. Now if we do the next step, as you know that the process of finding out GCD, then I place this number here, and again I count the table. It 1 times 114, so 5 here, so on subtracting, and 1 here. So I can give, what is this 129? I have given the name of B, this is B. Q1 I used, this is another quotient, I give it name Q2, and I used name R1, so this is R2. So I can write this 129 as 129 is equal to, you don't do this theorem in this pattern, I am just explaining you. Okay, I am just explaining you here. So 114 multiply with 114 multiply with 1 plus remainder 15, where remainder 15 is less than 114. Now I am writing their names. What is 129 here? 129 is B here, and 114 R1. What is 1 here? Q2, and what is 15 here? R2. And what is 15? R2. What is 114? R1. Okay, if I do the next I proceed this procedure. What I do, I make this number as a dividend. So 15 sevens are 105. So the remainder is 9. I give the name. What is 114? What is 114? 114 is R1. What is 7? 7 is Q1. And what is 9? I have given R1, R2 names. So this is, we suppose, R3. So now I can write 114 is equal to 15 multiply 7 is equal to plus 9 and here 9 0 is greater than 0 is less than 9 and less than 15 by Euclid theorem. So what are, we have given names to 114. 114 name is R1. What is the name of 15? R2. What is the name of 7? Q3. Okay, Q3. I have given Q1, Q2, Q3. So this is Q3 plus R3 and 0 is less than 9. 0 is less than R. 3 is less than R2. Okay. Now if I continue this process, I make this 15 as a dividend. 9 ones are 9. Here 6, I make this as dividend. 6 ones are 6. 3, I make this as a dividend. 6, 3 twos are 6, and remainder is 0. Now I just write these for your clear understanding. Okay, I can raise these. I write this for your only understanding. Okay, if I continue this process, suppose I write here, let RK is GCD of A and B. I suppose it. So if I continue this process, what will be the next terms? Can I write here the next term of R2? If it is R1, this is R1, R2, so R3 comes here. If this is 2, then with Q3, then Q4, R1, R2, R3, then it is R4. So R2, R3, R4, R3. Okay, by the help of series, I wrote this. If I continue this process, what is the last one is GCD. We suppose that after doing many steps, not in this question, any other question, general question, after doing many questions, this will become the GCD of, that is RK. We give it the number RK. If I have here, you see, R2 as a divisor, what is, if this is R3, then this is R4. For example, this is R4 and this is Q4 and this is R3. When at the dividend place R1, then this is R2. One more, then number is one more. If this is R1, this is R2. If this is RK, then this is RK minus 1. Okay, this is RK minus 1. Okay, so and this is, what is this? If this is R2, then next divisor is R3. If this is R1, next is R2, this is R3. and this is the next remainder, so rk, so this is rk plus 1. Now can I write, and if this dividend is, this divisor is r1, then quotient is q2. When divisor is r2, the quotient is rq3. If divisor is rk, then quotient will be qk plus 1. One more here, if it here 2, then here is 3. So can I write rk, can I write rk is k is equal to rk minus 1. Okay, I'm writing this, k minus 1 is equal to rk into q, k plus 1. I am multiplying divisor with quotient, and what is remainder? Remainder is 0, because rk plus 1 is equal to 0. Okay, after this, with this series, I can write the above terms of this. Here R2, then here is R1. Okay, here is RK minus 1, then above term is RK minus 2. Here is 3, here is 2, here is K, then here is K minus 1. Here is 4, here is 3. If here is K plus 1, then other is, above is k minus 1 and q k, and if here is 4, here is 3, so r k. Okay, where 0 is less than rk is less than rk minus 1. From here, if r4, then here is r3. Also I can write the above term rk minus 3 is equal to rk minus 2 q k minus 1. From this, 1 less. Okay, and from here, what is the number with q r k minus 1, and 0 is less than rk minus 1 is less than rk minus 2. Okay, I can write by making this series, considering this series, I can write preceding steps. Okay, now I'm going to raise this example. Okay, I'm going to raise this example. Now this is rk plus 1 is equal to 0 here. What I'm doing here, I'm taking the value of rk from here, the value of rk. What is rk? Rk is equal to rk minus 1 minus, this goes here from right to left and becomes minus r k minus 1 q k. Here I'm going to plug in the value of k minus 1. Okay, you don't circle it, I'm just for your understanding circling it. From here I find out the value of k minus 1. What is k minus 1 value? rk is equal to rk minus 1 minus rk minus 3 minus rk minus 2 k minus 1 into qk. Okay, multiply this inside, distribute it. This multiply with rk minus 3, rk minus 3 qk. This also multiply with this rk minus 2 qk minus 1 qk. Okay, just take common for your understanding. I am circling these two numbers are k minus 2. This is rk minus 2. Okay, sorry, this is rk minus 2, because when we find the value of rk, this goes here, this is rk minus 2. Okay, this is rk minus 2. We are taking common rk minus 2 from these two terms, this term and this term. What comes here? This is 1, and what will become it when you multiply with minus? This term become plus. And if this goes k rk minus 1 outside, what it will be? Rk minus 1 qk. Okay, now what is the remaining term? Rk minus 3 qk. So now I take rk from here and put this rk minus 1 value. Then I put, if I goes backward procedure, I put the value of rk minus 2 here. Okay, and then I put rk minus 3, then r4, r3, r2. What is this? This is rk, this is rk, and what is this? This is the gcd. This is the gcd. What is gcd? D here. This is a gcd. And what is its will be, if we proceed this procedure, what it will be of the form? This is of the form we get by ax substitution ax plus by. Okay, this is of the form ax plus by. By back substitution then we say that we can write d as the form of ax plus by.